Hey, welcome to The Explainer. Today, we are pulling back the curtain on the invisible systems that pretty much run our modern lives. We're going to explore how computers went from just, crunching numbers to actually sensing and controlling the physical world all around us. So let's jump right in and see how it all works. I mean, really think about it for a second. Your thermostat, your traffic lights, all these automated systems, they can feel a little bit like magic, right? But they're all built on the exact same core principles. They aren't just running on some simple timer. No, they're actively reacting to the world. And by the end of this, you'll get exactly how they do it. All right, so the whole journey begins with one simple act, observation. Before a computer can do anything, it first has to see, or maybe a better word is sense, what's actually happening. This is the world of monitoring. So what is a monitoring system? Well, at its core, it's just how a computer gathers information. It's not about making decisions or taking action. Not yet. It's just about collecting the raw data. Temperature, pressure, light, you name it. This is the foundation for everything that comes next. Now, this flow here shows a really crucial translation process. See, a sensor picks up something physical, like heat, and turns it into an electrical or analog signal. But here's the problem. Computers don't speak analog, so this tiny but absolutely vital little chip called an analog-to-digital converter, or ADC, has to act as a translator. It turns that wavy analog signal into ones and zeros the computer can finally understand. Honestly, this is the easiest way to think about it. If you want a computer to understand the world, you have to give it senses. A temperature sensor is like its sense of touch, a light sensor, its sense of sight, and so on. They are the bridge between our physical world and the digital one. A modern weather station is a perfect real-world example of this. It's not just one sensor, it's a whole team of them working together. Each one measures a different piece of the puzzle: the air temp, the atmospheric pressure, the humidity. The computer then takes all that data and puts it together to build a complete picture of the weather, all without a single person having to step outside. So we've got all this data pouring in from our sensors, which is great. But there's a catch. How do we know that data is actually right? That's where this next step comes in. Exactly. I mean, what good is any of this if the data is wrong? If your thermostat sensor is off by just 5 degrees, your heating system is basically useless. Or worse, it's incredibly wasteful. The data is only as good as the sensor collecting it, which is why the process of calibration is so important. Calibration is basically a reality check for a sensor. You take a known correct value, like, say, the temperature of boiling water, which we know is 100 degrees Celsius, and you check if the sensor agrees. If it doesn't, you adjust it until it tells the truth. It's how we keep our digital senses sharp and honest. And this isn't a one-and-done kind of thing. Just like any tool, sensors wear out over time. Physical parts can erode, the electronics can drift. It all leads to less accurate readings. So regular calibration isn't just a good idea, it's absolutely essential maintenance if you want trustworthy data. And how you calibrate really depends on what you're measuring. For something that's pretty stable, a simple one-point check against a single known value might be all you need. But for a variable that's constantly changing, like the outdoor temperature, you need a more robust two-point calibration, checking it at both a low and a high point to make sure it's accurate across its entire range. Okay, so our computer can now sense the world, and it can do it accurately. It's officially a reliable observer. But now we get to the really exciting part. How do we get it to stop just watching the world and start doing something about it? And that, my friends, is where a control system comes in. It takes the data from the monitoring system, makes a decision, and then takes an action. The key players here are called actuators. These are the motors, the heaters, the switches, the things that do the actual physical work. And here's the really clever part. The system's action changes the very thing it's measuring. And this is the secret ingredient. The magic that makes it all work is something called a feedback loop. It's a continuous cycle. Sense, compare, act, and repeat. It's what allows a system to not just act, but to constantly react and adjust itself to stay on target. This automated greenhouse is the perfect way to see it in action. So you tell the system, I want it to be 22 degrees in here. That's the preset value. Then a sensor reads the air and says, hey, it's only 19 degrees. The computer compares those two numbers and goes, nope, that's too cold. So it acts. It sends a signal to an actuator, in this case the heater, to turn on. The heater does its job, the room warms up, and the sensor reports the new, higher temperature back to the computer, starting the entire loop all over again. It's this constant, self-correcting process. So once you understand this idea of a feedback loop, you start seeing it absolutely everywhere. These monitoring and control systems aren't just for high-tech labs or greenhouses. They are deeply, deeply woven into the fabric of our everyday lives. Think about a smart motorway that uses sensors to detect traffic jams and then automatically lowers the speed limit, or a traffic light that uses sensors in the road to sense how many cars are waiting and adjusts its timing. Even a burglar alarm uses motion and pressure sensors to decide when to activate its actuator, which is a really loud siren. They are all running on that same sense, compare, act, feedback loop. And when you take all these individual control systems and you hook them all up to the internet, well, that's when you get the Internet of Things, or IoT. This is what makes a smart home possible, where your phone can become a single remote for your lights, your thermostat, and your security system because they can all talk to each other. Now, this increasing level of automation is incredibly powerful. It offers a level of convenience and efficiency we've literally never seen before. But, and you knew there was a but coming, like any powerful technology, there are trade-offs we really need to consider. On the one hand, no doubt about it, these systems are way more accurate and efficient than a person could ever be, saving us time, energy, and money. But then you look at the other side of the coin. There's the high initial cost to set them up, the potential for certain jobs to be displaced, and even our own growing dependency on them. I mean, what happens when the power goes out, or when these internet-connected systems become targets for hackers? The convenience we gain also comes with brand new vulnerabilities. So from a simple thermostat in your home to a traffic grid that manages an entire city, these monitoring and control systems are making our world more efficient and responsive. But as this web of sensors and actuators grows more and more complex and interconnected, it really forces us to ask, are we prepared for the trade-offs that come with it? That's definitely something to think about. Thanks for joining me on this explainer.